In my 14 years of journey as an IIT JEE Maths faculty, I have seen students facing a lot of problems, especially in questions of summations in binomial theorem. So in this video, I am going to simplify your life by giving you 5 different kinds of questions and 5 different types of tricks how to solve those 5 different types of questions based on series in binomial theorem. So without any further delay, let us start with it. Now in this next problem type, what you can observe is we have binomial coefficient divide by constant. So this is slightly different from what we did earlier, but the 4-step process still remains same. So again, if I take this question, what I am going to do is again write the general term. So in this case, in the first step, the general term is going to be NCR by R plus 1. In the second step, we are going to apply a property. See, now earlier we applied this property in the order of n by r, n minus 1, cr minus 1. Now we'll apply it in the reverse order. That is, here in this same formula, if I replace n by n plus 1, r by r plus 1, what we will have is n plus 1 by r plus 1 NCR. Now we are going to apply this property in the reverse order. Like that would mean if in my question I have been given NCR by r plus 1, you can see that there is an n plus 1 missing. So I will multiply and divide by n plus 1. Now this is where my property will get applied. This will become n plus 1 CR plus 1 by n plus 1. So this application of property is the most crucial step in this kind of question. Once you have done this, in the third part, we are going to do exactly same what we did earlier. We are going to rewrite the series. So if you rewrite series, 1 upon n plus 1 will come outside. And inside, if I start putting value, the first value of r was 0. So this will become n plus 1 C1. Then n plus 1 C2. And this will go till n plus 1 Cn plus 1. Now in the fourth part, as we always do, we are going to use some standard result. We know that if we have NC0 plus NC1 plus NC2 till NCn, the answer is 2 raised to the power n. But in this case, in place of n, we will replace n by n plus 1. So the result will become n plus 1 C0, n plus 1 C1, n plus 1 C2 till n plus 1 Cn plus 1 is equal to 2 raised to the power n plus 1. So now you can clearly see that what I want fundamentally is the value of this part. So if I want to do that, I will have to take this n plus 1 C0 on the other side. So the answer of my series that is given in the question would be 1 upon n plus 1. This will become 2 raised to the power n plus 1 minus n plus 1 C0. Which in turn can be written as 1 upon n plus 1, 2 raised to the power n plus 1 minus 1. That is the answer to this question. Now in this case, there is no shortcut that can be used. You will always have to go through the standard 4 steps that we discussed earlier. Let us take one more question. What happens if there is a minus sign in between? The plus minus alternate plus minus signs are there. Again, we can follow the same 4-step process. In the first one, I am going to write general term. That will become n CR by R plus 1, but you also have minus 1 raised to the power R. Second, we are going to apply the property. So for applying that, I am going to multiply and divide by n plus 1 and apply the property as we are doing earlier in the reverse order. So the first term, this part will become n plus 1 CR plus 1. And then we have n plus 1. In the third step, we are going to rewrite series. So if I rewrite series, what I get is 1 upon n plus 1. Put the value for r from 0. So this will become n plus 1 C1. Then minus n plus 1 C2 plus n plus 1 C3, so on and so forth. Now in the fourth part, we are going to use standard result. So we have a very standard result that goes like this: NC0 minus NC1 plus NC2 minus NC3. This is equal to 0. Now here I will replace n by n plus 1. Again write it down, nc naught minus n plus 1 c1 plus n plus 1 c2 n plus 1 c3, and this series would be equal to 0. Now we can see that I don't want the whole series. My series starts with n plus 1 c1. So these terms I will take on the other side. So it becomes n plus 1 c naught is equal to n plus 1 c1 minus n plus 1 c2 plus n plus 1 c3, so on and so forth. So we have got our answer. So my answer to this question becomes 1 upon n plus 1 c naught. That is 1 upon n plus 1. Now we can see that the process has remained same, just the series has changed towards the end, and the answer, more importantly, is not 0. When there was binomial coefficient into a constant, the answer were always 0 for such kind of questions when there were alternate plus minus signs. But now when that has not happening, you can see that the answer is not equal to 0. Very important point to be noticed. You can keep on doing this process. Let me do 2 more questions and then we'll move on to the next problem type. If I take this question, again I will write my general term. In my first step, I will do it directly. NCR by R plus 1, R plus 2 is given. So in the second part, I am going to apply property. First, I will multiply and divide by n plus 1. Now, if I combine these terms, based on my property, this will become n plus 1 CR plus 1 by n plus 1 R plus 2. One more time, we are going to multiply and divide by n plus 2. So n plus 1 was already there, 1 n plus 2 will come in the denominator. We have n plus 1 CR plus 1 by R plus 2. Again apply the property, this will become n plus 2 CR plus 2 divided by n plus 1 n plus 2. The third part, we are going to rewrite the series. So if I rewrite the series, 1 upon n plus 1 into n plus 2 will come outside, and inside becomes n plus 2. If I put the value of r as 0, will become 2. N plus 2 C3, and it will keep on going till n plus 2 Cn plus 2. Well, we can see in the fourth part that the standard result is Nc naught Nc1 till Ncn is equal to 2 raised to the power n. But in this case, we'll have to replace n by n plus 2 now. So n plus 2 C naught, n plus 2 C1, n plus 2 C2, n plus 2 C3. It will keep on happening. The answer will be 2 raised to the power n plus 2. So once you have got this, you can see that we want sum of these terms. So these terms will have to subtract from the right hand side. You can see that as a result, the answer of my series becomes 1 upon n plus 1 n plus 2 is 2 raised to the power n plus 2 minus n plus 2 C0 minus n plus 2 C1. We can simplify and get the answer. You can see that same 4 steps. There is no mystery to it. If I put alternate plus minus sign, the same process would be there. The last step result would change. Everything else will remain same. In this part, you can see that again, we'll have to do the same thing. But instead of first 2 terms that were left in this case, there would be 3 terms left. But largely, essentially the same process. There is nothing new. Let us do this question. You can see that there is a slight modification to this question, and similar kind of question we saw when we were doing constant into binomial also. Again, the 4 steps. The first term would be to write the general term. So that becomes NCR. There is R plus 1, R plus 2 and 2 raised to the power R plus 2. In the second part, we are going to apply property. 2 raised to the power R plus 2 is fine. We will multiply and divide by n plus 1. NCR by R plus 1. Now these terms will combine. This becomes 2 raised to the power R plus 2. N plus C R plus 1 by n plus 1 into R plus 2. Apply the same concept one more time. Multiply and divide by n plus 2. So what is left in the denominator is n plus 1, n plus 2. And we have n plus 1 CR plus 1 by R plus 2. Again apply the property. So what are we getting is 2 raised to the power R plus 2 by n plus 1 into n plus 2. And here what we have got is n plus 2 CR plus 2. Now it is time to do the third step. So while doing the third step, we need to rewrite the series. So 1 upon n plus 1, n plus 2 will go outside because it is constant. And if I start putting the value from r from 0, this becomes nc2, n plus 2 c2, 2 raised to the power 2. Then n plus 2 c3, 2 raised to the power 3, so on and so forth. Now once you have written this, in the fourth part we have to apply the result. So we know that 1 plus x raised to the power n is nc0, nc1x, nc2x square and ncn x raised to the power. So what we are going to do is replace n by n plus 2 and replace x by 2. These two things we are going to do. If I do that, the left hand side will become n plus 2 c1 into 2, n plus 2 c2 into 2 square, and so forth. You can see that we want the sum of this part of the series. So if I write the final answer, it is going to become 1 upon n plus 1 into n plus 2. 3 raised to the power n plus 2 minus the first two terms, n plus 2 c0, n plus 2 c1 into 2. This becomes my answer. You can see that the process is same, just some results change and the general term would change, nothing else would change apart from that. To apply these 4 steps, all such questions you can easily solve in the exam hall. 60 days to JEE Mains. Let me tell you something that nobody else will. The brutal truth. Right now, you have doubts from class 11th you never cleared. Topics you are avoiding, formulas that you kind of remember. And you are thinking 60 days is enough to fix everything. Here's the reality. It's not if you study randomly. At PracBee, we have produced 10 times better result than national average and helped more than 500 plus students jump 80 plus marks in last 60 days. How? They stopped trying to cover everything and focused only on high weightage topics. They cleared every doubt. They had a strategy into place. And that's what Last Lab Booster program does. Senior ITN faculty sit with you and develop a 60-day roadmap. Expert teachers guide you 1:1 daily. Every doubt is cleared in 24 hours. Not random prep, but strategic warfare. Ashesh, Ditya, Sauri, Sarthak, we are all able to improve from 150 to 250 in a matter of 60 days. Real students, real result, 60 days. But time is less and our slots are even more limited. Click the link below, book a free strategy session or regret it on 1st Feb. 60 days, your move.